Okay, by the end of the American Revolution, the United States has to become um, commercial agriculture. Commercial agriculture has to be the way, because that's what England has set us up for. England has made it so that we have not been manufacturing, and it will take us a few generations for us to come back up to the level of manufacturing and industrialization that England has. England goes through industrialization before the United States does because of the way England had kept us back in previous periods. Okay. However, Thomas Jefferson, in his philosophy, believes that we should maintain this agrarian attitude, this agrarian ideal. Jefferson believes that this would put us in a position that no other country in the world was in. We could have such an abundance of resources that when we harvest our resources, we could sell it to the world at such a rate that we would be able to prosper through it. The Federalists, like Alexander Hamilton, are going to actually push our country to start manufacturing, to compete with England, not to merely find our niche in the place, but actually to become competition for English, especially, for example, like in the textiles industry, which we'll talk about here shortly. Initially, our country starts out as agrarian. As we attempt to increase our output and we start building machines. Some people call it pre-industrialization. I would prefer to call it mechanization. We build machines to create these labor-saving devices so that we can increase our outputs. Now, some of these machines we'll talk about now, but first we need to talk about this single crop. Especially in the South, there's two kinds of cotton that grow in North America: smooth seed cotton and green seed cotton. Now, smooth seed cotton grows really well on the coast, and as its name implies, smooth seed cotton has smooth seeds contained in the cotton ball. So whenever you take a cotton ball, you can rub the cotton ball and the seeds fall out. The cotton is ready to be carded and then put in a spinner and then spinned into thread, and then from thread to weaving. So the raw cotton is easy to process with smooth seed cotton, and it grows only on the coast. It's not resilient enough to grow inland. Green seed cotton grows inland and everywhere. As far from the Atlantic Ocean all the way to East Texas, green seed cotton flourishes in those regions. The problem with green seed cotton is that its seeds have little barbs, have little hooks on it. And so when you get the cotton ball out of the hull, you've got to pull the cotton apart in order to get the seeds to fall out. And so it takes a long time for it to process. Okay, it takes a whole day to clean 1 pound of cotton by hand. In 1793, a young man will graduate from Yale University, and he will come down south, first South Carolina, then to Georgia, to find some method of creating a machine that will decrease labor. Okay. When he gets to Georgia, he comes up with these ideas, and one of his inventions is this thing called the cotton gin. The man was Eli Whitney. Okay. The cotton gin is supposed to be a tool that had the potential to eliminate the need for slavery in the minds of some people that were looking at it. You take the raw cotton and you put it down into the hopper. First, another thing about the green seed cotton. The hull that the cotton ball grows in, when it pops open, it's got the hull is hard as bark. It's hard like bark. Plus, when it pops open, on the ends, there's like little claws. If you stick your fingers in there to pull the cotton ball out, these little holes will rip your fingers up. So the easiest way to pick the cotton is to break the whole bulb off and throw that in your bag, making another step for trying to clean the cotton. What Whitney's machine does is you put the raw cotton with the hulls and the seeds, you put it in the hopper, and it comes through this paddle wheel. The paddle wheel trounces the cotton to the point that it causes all the trash, all the hulls and everything, to fall out of the raw cotton. And then it goes through a small gate. It's forced through a small gate with all the hard pieces falling in the trash. And the cotton is then pressed against this metal mesh. The metal mesh is just narrow enough for the cotton to go through, but the seeds can't go through it. And through the metal mesh are these saws. The saws, as they turn, they cut the cotton ball into basically into strips. The seeds will fall down into a collection basket, and the cotton lint that's just been cut up will pass through the mesh and is collected down here in the raw cotton. Now, Eli Whitney's invention is going to change the shape of the South. Now, with one of these cotton gins, you can process 50 pounds of cotton a day. It can be processed and cleaned in a single day. So if you have 4 cotton gins, you can process 200 pounds of cotton every day with each one running. English textile markets need that raw cotton because they are increasing their output and production of fabrics. In 1792, 138,000 pounds of cotton was exported from the South to England, right? The year before the cotton gin. The year after the cotton gin, 1.6 million pounds will be exported to England. And then by 1800, 6 years later, 35 million pounds. And by the time we reach 1860, we're looking closer at 70, 80 million pounds of cotton every single year being exported to not only England, but also to France and to Spain, all over the world at this point. But the two primary groups, Spain and England. Now, again, as I said, some people viewed the cotton gin as having the potential to eliminate the institution of slavery. The problem was, up to this point, up to the 1800s, slavery was becoming not cost effective. It was no longer, because it costs a lot. It costs a lot. So slavery was some historians believe, on its way out, ready to die on its own, under its own weight. The problem for the cotton gin, when the cotton gin comes on the scene, it does diminish the labor required in one aspect of cotton production. I mean, to go from 1 pound of cotton to 200 pounds of cotton a day, that's an enormous amount of increase and an enormous amount of labor saving. However, if you can clean 200 pounds of cotton a day, you have to have 200 pounds of cotton picked. And the problem for the cotton gin, why it did not have an impact on slavery in a positive way, it meant that these farmers had to have more slaves to pick more cotton, because now they can process more and more and more, and the cotton gins become bigger and bigger. And especially when they finally hook these cotton gins to water wheels and allow for the water transmission to increase the productivity, each gin itself is processing hundreds of pounds of cotton a day, which means in the South you needed more slaves. This invention, even though some would say could have potentially eliminated the need for the institution of slavery, the technology carried with it problems that made slavery cost effective. It made slavery cost effective. And this cotton, this is going to be the thing all the way through the Civil War. Cotton is going to be king. The South will use its cotton crop as its primary negotiating tool when dealing with England and France to get them to help them during the Civil War, which is an important thing for us to look at a later date. Now, Eli Whitney is not only, I know I gave you a writing assignment and I said to look at John Deere and Eli Whitney and Cyrus McCormick. I also want you to, in the list of individuals, I want you to add Eli Terry. Eli Terry is also an individual that you can utilize to do research on these early pre-industrial individuals. Eli Terry is going to begin. He's a clockmaker, and he's a master clockmaker. However, clocks are expensive. In the time period, clock parts are made of bronze and brass, and they're very expensive. They're very expensive, and they're all handmade. What Terry's going to do is he's going to develop a clock mechanism that works using wooden gears. And he's also going to establish a principle of standardization. If each part can be made to exact specifications, then through this standardization, you can begin mass production. Okay? And so what Eli Terry's clock is going to do, he's going to make clocks that are actually affordable, to go from $20 a clock down to just $1 or maybe $2 a clock, so that everybody can afford one. This mass production, through standardization and mass production, are going to help to lead us directly towards the towards industrialization. Eli Whitney is also involved in this notion of standardization and mass production. As you'll do in your research, Eli Whitney will begin this firearms factory, this firearms plant that's going to mass produce parts, interchangeable parts, to build rifles for the war effort. And so in doing these interchangeable parts, he's going to make it possible that instead of one gunsmith being able to produce one gun in 2 days, he's going to make it so that one gunsmith can put together 10 guns in a day, simply because of this fact that you've got parts being made all over the place, and since they are interchangeable and standard, they can just be brought together to an assembly plant and put together. So Eli Terry's clock is going to be another one of these early inventions that's going to demonstrate the potential of mass production because of things like standardization. Now, the United States, at this time period, we're looking at around the 1820s. The United States we're going to start growing. It's at this point they start finding a difference between the southern part of the country and the northern part of the country. And the primary difficulty is going to be this notion of mechanization and the institution of slavery. In the north, there is no institution of slavery, and so in order to save labor, the people in the north are going to be forced into mechanization. In the south, if you need labor, what you need to do is just get more slaves. You just get more slaves. Now, look on the map. I'm not sure if you can see on the map, but in the south, there's only a few states that have between 50,000 and 250,000 individuals, right? New Orleans, of course, because it's a massive port city. New Orleans has it. And then all of the other large northern cities, or southern cities, St. Louis, which is in a slave state, Missouri, Louisville, Cincinnati, and then up here, not even Richmond, but up here Norfolk, which is a big shipbuilding area. Not Norfolk, that's Washington. So the South has no large cities, nothing over 250,000. Nothing over 250,000. However, in the North, you've got an enormous number of these large, heavy populated cities. You've even got 3 cities that have more than 250,000 people. You've got, let's see here, you've got Philadelphia, and you've got New York, and you've got Brooklyn. You've got these cities that have in excess of 250,000 people. The thing that's going on is you're seeing the development of 2 separate kinds of cultures, 2 separate kinds of lifestyle. The South is purposely maintaining its agrarian nature. The South is purposely maintaining this idea that our wealth comes from land. In the North, we've got other avenues, we've got other things. Sure, these large cities are needing massive quantities of food sources, because once you've got 250,000 people living in a city, you don't have most of those people growing their own food. So they have to get their food crops from back here, and the foods have to be brought towards these large cities. As we become more industrialized, our divisions of labor become far more complicated. Now, some of the things to increase production in these western areas, Ohio, Indiana, Illinois, in these western areas, are some of the inventions of individuals you may have heard of before. For example, John Deere. John Deere is a blacksmith, and he invents something that will be referred to as the singing plow. The singing plow is a plow that has plow heads made of steel rather than iron. See, iron is a heavy, heavy metal, and in order for it to be useful, it has to be thick. It has to be thick. Cast iron has to be thick. And it also is very heavy, it is brittle, and it is soft. If you're using a plow, it's heavy, and so it causes your horse to have to work extra hard. If you hit a large rock, you stop dead in your tracks. You have to pull the plow out of the ground, and in some cases, you have to get your file out and file it back until it's got a sharp edge on it again. And in some cases, if you hit something hard enough, your plow head is just going to crack, and you have to take the whole thing to a blacksmith. John Deere starts using this steel. The way you make steel is you repeatedly fold raw iron over and over and over, and you heat it and you pound it and you heat it and you pound it and you heat it and you pound it and you fold it and you fold it and you fold it. Many of the items. Well, let me show you for an example. We're going to take. I'm going to walk off screen for a second. I want to show you an example of the kind of steel. This is an old hunting knife. This is an old hunting knife. It is made of a kind of steel. I'm going to get my wife to stand up so she can make sure that I'm showing it properly. It's made of a kind of steel called Damascus steel. And this is the blade. My boss is it not focusing in?
It's just a shadow.
It's,
oh no, okay, if you go back like that right there, yeah, that's good. Now
okay.
Tip it up a bit. Yeah,
like
there
that?
you go. Yep.
This is Damascus steel. What the blacksmith does is he takes this piece of iron and he creates a block, and then he heats it up until it's red hot, and then he flattens it out, and then he heats it up until it's red hot, and then he folds it up into a block again, and then he heats it up till it's red hot, and then he flattens it out again. Each one of these areas is a fold. Is like a fold for of the steel, and you can see it. It's hard to see here, but oh, I wish you could see the side. On the side, you can almost see the.
Yeah,
I'm trying to catch the light so that you can see. You can see the number of times this blade has been folded. Anyway, but that's a Damascus steel knife. Okay, that's the kind of steel that John Deere and these blacksmiths are using. It's strong, it's resilient, it holds an edge because of the basically the pounding on this thing, the impregnating of the carbon from whatever heat source you're using. The impregnating of that carbon makes it so that the steel becomes resilient where the iron isn't, and you can use a much thinner piece of the steel to do the same amount of work as a very thick piece of iron. And so all John Deere has to do is brace the back of these two plow heads, and it just flies through the dirt. The horse it's much lighter for the horse to pull, and it flies through the ground. As it goes through, it instead of stopping whenever it hits a rock, it literally knocks the rocks out of the way, and when it does, the plow goes bing. It makes a sound, like a bell ringing. And as it goes through the ground, it goes bing, 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 bing. Basically, it's why everybody started calling it the singing plow. Now, this invention is going to double the amount of fields you're able to plow in a single day because of this one tool. It's going to increase agricultural output so that people in Ohio and Indiana and Illinois that are producing food crops to send back to these large cities up north are going to be able to continue to make more and more food. And these cities will continue to grow larger and larger. Now, the second thing that's used during this period to increase crop outputs. I know it's hard to see. You can look this up online. Something called a cradle scythe. Okay, a cradle scythe is basically, you've seen a scythe. It's the thing that the Grim Reaper carries. It's a long stick with a big hooked blade on it, and you slice through the grass and you cut the grass and it falls down. Okay, then somebody comes behind you with a rake and rakes all of that grass into a single row, and then somebody comes behind them and ties up each one of the bundles so that you can take the grain to threshing and you can get the wheat off of it. What the cradle scythe does is it has these wooden, I know it's hard to see from here, it's got these wooden, oh, I've got my pointer though. It's got these wooden fingers. It's got these wooden fingers that run parallel. You've got the blade here, but then it's got these wooden fingers that run parallel to the blade. And as you swing the scythe, these fingers gather up the wheat. And when you come back to make your next cut, it drops it in a nice, neat pile. And each time you cut, it gathers up the wheat and it drops it in a nice, neat pile. And so now you've decreased the labor necessary to harvest a field by 1/3. Plus, the cradle scythe increases the amount of farmland that can be harvested by a single person from less than 1 acre a day to 2 and 3 acres a day. So again, it decreases the amount of labor necessary to harvest the field, plus it gives the ability for this guy to harvest up to 3 acres a day. The next tool is Cyrus McCormick. Cyrus McCormick is going to be, this is a true harvesting machine. Cyrus McCormick, I'm going to post a video about Cyrus McCormick and his mechanical reaper. McCormick is going to invent this machine that's going to change from the benefit of harvesting 3 acres a day to Cyrus McCormick's machine of harvesting 12 acres a day. It is a machine that is operated by gears and is drug along the ground, and the primary flywheel uses the ground as it moves. McCormick and these guys with these fields are going to start harvesting enough food that will allow these large cities to become productive, allow these large cities to have their populations increase, and from this. Now, when I come back, we're going to start talking about transportation, and we're going to start talking about the factory system, and so that'll be what's on the next video.